Hi, my name is Solaine Zhao, and I'm a rising second year computer engineering student at UCLA. The topic of my research is optimization techniques for dynamical system identification, and I worked under Professor Lieven Vandenberghe in his lab with my partner, Ben Lanir. So data collection and manipulation is very important in all professional fields, so it's always important to have clean and correct data. However, sometimes data collected in the form of signals can be noisy or obstructed. So our research goal was to find a tool to clean and fill in this corrupted data. So we represented data as being part of a dynamical system or a state-based system that changes over time according to a fixed set of rules. And a pendulum is a great example of a dynamical system because its motion depends on its current state or its angle and velocity, while its motion is described by Newton's equation F equals ma. So our project was an optimization problem, which involves finding the best set of values to meet some criteria. And this criteria is often in the form of an objective function that we're trying to minimize or maximize. So for our case, our optimization variable, or the set of values being searched for, was the final cleaned version of the data. So we used MATLAB as our primary coding software, and then we also used a couple of different resources to collect data sets, including this DAISY package and also some biomedical signals for intracranial pressure estimation. And these were just different resources that we could test our function on. So now I'll explain the step-by-step methods that we took. So first, we gathered test data from various dynamical systems that we either found online or we created ourselves. Second, we coded an optimization problem by creating an objective function, and we would try to minimize this objective function, which I'll explain more about later. Third, we compared our clean data to our original data so we could see what needed to be adjusted. And fourth, we adjusted the various weights and numbers in the equation so we could get better results. So now we'll talk a little bit about our mathematical methods. So I mentioned the two-part objective function that we're trying to minimize already. So the first part involves the nuclear norm of a special Hankel matrix. So what minimizing this does is take all of the noisy data and try to fit it to a dynamical system as best as possible. And this is because when we have a perfect dynamical system, we're able to predict missing values and values in general pretty easily, which will help us clean the data. And the second part of this cost function is basically an error term made up of the difference between the optimized value and the measured value at a point. And this is really important because we want to minimize this difference in order to get the most accurate version of the cleaned data. So overall, we're trying to minimize the sum of these terms, and the CVX package in MATLAB is a software package. And it can actually do this for us and give us the final cleaned matrix, which is really awesome. So here are our results. And for results, my partner and I plotted the original data, the corrupted data, and cleaned data, where the original is this orange line. The corrupted are just the green points. Clean data is the blue line, and the X's are missing data points. So as we can see from our plots, the cleaned or blue line is very close fitting to the original orange line. And it's actually amazing that given so few points of data, which are the data points marked with the green circles, and so given so few data, and even after the data has been corrupted, the software is able to reconstruct the original plot to an accuracy of almost 90%. And so this fourth graph that looks different from the other ones is a graph of the singular values. And this also represents how successful our function is too. So the more values that are closer to 0, the better the minimization. And we can see that the values drop really, really quickly, all the way down to 10 to the negative 6 right here. So overall, our experiment with the test data supports our mathematical model as a really good way to clean and interpret data. So our next steps will be to use some more advanced optimization techniques. So instead of using the CVX package in MATLAB, we're going to try to write our own optimization techniques. And then we also want to try to implement it in Python. And then third, we're going to try to use some real world applications and real data. So here are our references, and here are our acknowledgements. Thank you so much.